All right. So today we will do this basic security policy in the firewall. Right. That's the topology that we're gonna use. R1, which is there in inbound, or sorry, name if in. This is outside interface, and this is DMZ. R4 is in DMZ. IP addresses is as per the diagram, what you see over here. Right. So as per the task, what it says, the configure ASA with the policy that ping and telnet are allowed from the inside subnet to the outside subnet and a DMZ, right? So which means, as we already discussed, ICMP, there are two ways actually to do that, to achieve this. Either you configure under the policy map, you configure this ICMP inspection, so that way ICMP will be allowed. And anyways, for the telnet, TCP is already allowed under the policy map, so you don't have to actually allow it. All right. So what I have to allow only ping. So there are two ways. This we already have seen before. Now we'll go with the this configure this inbound ACL. So now we have to configure an inbound ACL, which will make sure that the ICMP traffic is allowed.
Okay.
Right. So how to do that? How to achieve it? So yep, these are the routers. Let me expand it. R1, R2, and R4. Quick verification. We have already configured the dynamic protocols over here. So I do have show IP route in R1. Just for the explanation, here we are using RIP, and we are using OSPF over here between firewall and R2. Here we are using EIGRP between R4 and firewall.
Yes.
I believe I am audible to everyone, right?
Yeah.
Okay. And we have also performed the redistribution in the firewall, where OSPF into RIP and EIGRP, EIGRP into RIP and OSPF, and RIP into EIGRP and OSPF, similar. So I see here I have the, I am learning all the prefixes from other protocols. So our routing is working fine, but if I ping maybe let's say 2.2, which is, so I am initiating the traffic from actually inside to outside. So inside the security level we have made it 80, outside it is default 0, right? So as of now, yep, I see that it is working. Now I have to see in the firewall why it is working. With do we have some configuration that we have configured? We'll do one thing, clear configure and access list. And access list. So in case if there is any access list configured, it will clear it out. Now if you see here, we don't have actually configuration. We don't have any reachability between them. One moment, guys. Right? So we don't have any reachability. Now how to achieve this? So now you are aware of the topology, correct? We are initiating the traffic from R1 to R2, where I have the security level 80 here and the security level 0 over here. What we have studied so far is, if we initiate the traffic from higher level to lower level, the traffic is permitted, right? Why it is permitted? Because it is only permitted when you have configuration under the policy map. So if you don't have under this policy map, which is in this case, it is inspecting as TCP and all, it is inspecting, but ICMP is not inspecting, hence it is dropping the traffic, right? So in order to do that, as we discussed, there are two ways. One way, ICMP inspect, another is access list. Yep. So let's go to our command prompt. All right. And one moment. Just give me a moment. So in order to configure the access list, we have to also make sure that the traffic is permitted, right? So how we have to achieve? So we have to configure an access list, right? And we know very well how access list works actually in Firewall, isn't it? Is it clear?
Yeah.
We are aware of how the access list works in the Firewall. Okay, let's go to the Firewall. And configure the access list. So access list, I'll say outside in or out and in. Permit, I'll permit the traffic for ICMP. So as of now, when R1 is sending the traffic, R1 is able to actually send it. What it is not allowed is the incoming traffic. What it is not allowed is the incoming traffic. So
Echo reply.
correct. What I'm doing in, let me debug ICMP trace, and we'll initiate one, from the R1 ping. You see, so the traffic, it is hitting to the firewall, and it says that the echo request is coming from 101.1 2.2.2.2, right? But is it going to the another router? Is it going to R2? Right. So let's go to R2 and enable some debugs here. Debug IP ICMP, and again initiate the traffic and see whether R2 is receiving it or not. So ultimately R2 is receiving it.
Yes.
Right. But what is happening when R1 is sending ICMP to firewall, since it is seeing that the traffic is coming from high security level, right? It is sending it, but it is not doing inspection. Inspection means it is not keeping that file or the session in its table, session table. So it is just sending that echo request to particular 2.2.2 destination. Hence, that is where you are receiving this particular traffic in R2. R2 is also sending the echo reply, but when it hits, echo reply hits back to firewall, it is dropping it because firewall is not maintaining any session. Right?
Yeah.
So we'll create, access list out in permit and what ICMP, because we're gonna permit ICMP. I would say any source, any destination, right? And then we'll say ICMP or echo reply, means echo reply is permitted, right? That's the one. And the second is, I want to also make sure that it is also permitted to the DMZ. So we'll say DMZ and in ICMP echo reply. So with these two means the ICMP echo reply is permitted from R2 and R4. Clear?
Yes.
All right. Do I have to apply it anywhere, this access list,
Yes.
or the configuration is enough?
Interface.
We have to apply.
Interfaces, right? So here in firewall, we don't go under the interface and then apply the access list. Normally, what we do actually, we configure access group, right? The name of the access group could be anything. I would say out, in, and where do you want to actually, so the name of the access list over here, specify the name of the access list. Out, in, we'll say inbound direction. Inbound direction means
outside to inside,
right, inside, not inside and outside, in direction or out direction.
or
So this is in
incoming
direction.
traffic.
Yes. Now this interface means where I want to apply this. These are the name if interfaces which we have.
Outside interface.
Right. So we'll say out means this access list what we have created out in is allowed, right, for inbound direction when it hits, when the traffic coming to the name if interface name out. Clear?
Okay.
And then next is DMZ. DMZ in and in, and then here what I'll put?
DMC.
DMZ. Right. So let's again check the traffic. Yep, I see that the ping is successful, and moreover I am receiving this echo reply, sending it to 2.2. Also I'm receiving echo request, sending it to 2.2, and also receiving the echo reply from 2.2 and sending it to 101.1. Right. So that is how we create the access list to achieve another level of the ICMP traffic permission. Now if I want to initiate a telnet 2.2.2.2, this is not because of telnet, because as I told you, the telnet traffic is already permitted. You don't have to, because it is already inspected. It is there in the list of the inspection.
Yes.
Right. So you don't have to actually use that.
The session is terminated.
Because we have any session is terminated anyways. Is it clear?
Yeah.
All right, let's move to next task.
Can you just tell me the
Right. So that the previous task, it was for the traffic from higher level to the lower level.
Yeah.
Now this task is asking to perform the activity where you have to initiate the traffic from outside, lower security to higher security. By default, it will drop the packet. Firewall will never accept the packet, right? Neither from R2 nor from R4. So what is the solution for this? How to achieve this?
We have to create a policy.
And that to this task actually says that you are allowed to add only one line to the existing access list. Right? So this task says that you have to use only one line of access list. So in this case, what we have to use? We have to use this something called object group. Right? There is no need for object grouping. And what is object group? This method allows us to group up similar objects like host, ports, subnets, and then use group names in the ACL. So there are different object group types. These are the object group types: ICMP type, network type, protocol type, and service type. Means, object group actually, it resolves the problem or the scenario where you have to configure so many multiple access lists, right? So how object group actually resolves it? rather configuring so many access list entries in the firewall or iOS, you will configure the object group, right? And match those object group or apply those object group into the access list. So we'll see the configuration. As of now, you have to understand the task. Is it clear? Task, we have to allow SSH and telnet connection. Means we have to allow a SSH and telnet connection from R2. I want to telnet 1.1.1. R4 should be allowed to telnet and SSH 1.1.1. Clear? But since the traffic is being originated from the low level security level, the traffic will not be allowed. So that is where there's something called static packet filtering or static packet failover, right? What do we call it? We had discussed this is in last session the firewalls feature. We discussed about the stateful packet filtering,
Yeah.
and then static packet filtering. That's something called static packet filtering, where I am with the help of access list or with the help of object group and then apply it to the access list. We are allowing that traffic which is not permitted to telnet and SSH 1.1.1. I guess the requirement is pretty much clear.
Yes.
So in this task, you will learn if you have a requirement, something like that, where you want to, permit the traffic from the low level security level to the high security level, how to fine tune that, what all the requirement is that you have to configure in the firewall. Is it clear?
Yeah.
All right, so let's go to the firewall. Are you guys able to see the topology also?
CLA previously.
So you're seeing this firewall console, right?
Yeah. Yeah.
All right. So in order to do that, what I have to configure is you have to configure object group. One second, someone is. All right. So let's configure the object group. The task says what? Object and group. So if I do the question mark here, you see these are the object group types that we have already discussed: network, the protocol, security, service, ICMP type. So I'm going to use network. Network means you are going to mention all IP information, IP subnet information. So network, let's say MG or management host. So management and hosts. Right, enter. You are under the object group over here. Network, which object group? You are under the network object group.
Yeah.
Right, and then we'll say network object and the question mark. So you will see here the host, right? So we'll put host. Host means 32/32. So who all you want to permit so that they can telnet and SSH to 1.1. First 2.2.2.2, which is configured R2's loopback, and then the network object host you want to also permit 4.4.4.4, which is in DMZ R4's loopback, right? So this one object group is done. I've configured for the network. I have matched all the requester, all the the source, and the source in this case is going to be R2 and DMZ router. I'll configure one more object group. So object and group, and this time I'm going to configure the service, telnet and SSH, right? And then I'm going to configure for TCP. So TCP and then the port object. So under the TCP, since I'm going to configure the services over here and that to the TCP, so I have to configure the port object. That's the part of command, port object, and then the equivalent telnet. Let's say you'll have all the options over here. See all the services which you may see, HTTP, BGP, all the services are there. I'm going to configure telnet. So I'm going to configure telnet as well as going to configure SSH. These are the service object group. Is it clear? So the object group of service type is for grouping TCP UDP ports, in fact. So we need to specify what protocol we are going to match, either TCP or UDP. So we can also use TCP UDP both to match. Could be like DNS, it uses TCP and UDP both, right? Services in one role. And there is also a possibility to not specify the service type, and then we can use the service object. So I mean, it depends actually how you are using. Right now, since we have configured two object group, I have to use one access list, right? What we have before itself. So I have one access list which we have created, access list what? Access list, and then the out in, and then permit ICMP, isn't it?
Yes.
So the same access list name we will use here. So access list out in, this was the one access list, and this is going to be another entry. So we'll say permit. What I'm going to permit is TCP. Okay, so TCP is something that the TCPs I'm going to permit, but normally in normal scenarios when we configure access list, what do we mention? We mention the source and destination.
Yeah.
Right? We mention the source and destination.
Yes.
But here we are going to mention this source, but the source object group. So in this case, we're going to mention this object group, source object group. So the source object group, what I'm going to mention is what we have created there.
Management groups.
Yes, object group, MNT, I believe, isn't it?
Yeah.
Was that MNT?
Yes, right.
MNT and hosts.
Yes.
This was the object group where we have mapped the port services. And then we'll say, so this source is not yet over, right? When the source is this object group, the IP, I have to also give the IP. So host, when they are trying to use that services or that ports to 1.1.1.1. This is one part. After that, we have to mention what is the destination. Who is the destination? Normally, we give what? Instead of object group, this name, the TCP, and then the source port we give, right?
Yes.
Source port and then the IP address. Similar way that those ports are mapped here in object group. So I gave the object group and then the host 1.1.1. Now I have to another destination object. What is destination? So in
Telnet
destination,
SSH.
I'm going to give telnet and SSH. So telnet and SSH, right?
Yeah.
And that's all. In telnet and SSH we have what?
Permitting for Ethernet and SSH.
We have 2.2.2.2 and 4.4.4.4, isn't it?
Yes.
That's all. Is it specified object group MNT host not found? Okay. MNGT, is it? Show, run, and then object group. No worries. We'll check over here. So it is MNG host. It's my mistake. So MNG. All right. So out and in one direction was there. Now I'll create another access list. Similar, everything is going to be same, but this time the source will be the access list. I'm going to map under the DMZ in. DMZ and in. All right. Is it clear?
Yes.
So verification. So let's go for the
We need to
verification.
apply this object groups anywhere, like how we
That is
apply
already up. Yeah, that is already applied. Show, run, and access group. This is already applied here. Out in under the out direction and in DMZ.
yeah, okay.
Right. So that's what this task is saying, that you have to apply it on the previous access list. Not, you don't have to create in the new. Clear? Let's go to the. So if I initiate a telnet, let me undebug all, and telnet 1.1.1.1. So it will not go through. Why it will not go through? Debug
You need to,
TCP trace.
because you need to give from the source too.
Exactly. So as of now, it's not happening. We are telnetting because only 2.2 and the 4.4 is allowed. So I will say source loop back 0. Yep, it is allowed. Same. I will go and I'll go to R4. Yep, it is allowed. Right. We have to also allow the SSH. So first we have to configure SSH over here. Host name is already configured. So we'll have to configure IP domain name, maybe champ.com, and then we have to IP SSH version 2. We're going to use version 2. And for the SSH, what is the configuration? We have to create crypto key generate, crypto key, what's that? Is that?
Crypto key generate RSA.
Generate
RSA. Modulus.
and module, and they put the 1024. Let's say. Right, and put the username. So username champ and password champ. Now SSH 1.1.1.1, and then we have to use username Cisco champ. No, SSH and minus L actually. SSH minus L, and then this Cisco champ @ 1.1.1.1. Is it? Champ, I forgot this string actually. @ 1.1.1.1. Or this is, I actually forgot. 1 second. Specify SSH protocol version find that do not log in using this username. So -L is no, sorry, -L, and then the login name champ and the word 1.1.1.1. Yep.
Source loopback.
Yep. We have to put the source loopback also. So command string. SSH and then source loopback. So what we have to configure is we have to, I mean, this way you cannot actually, then in that case you have to configure from global mode IP SSH and source interface loopback. This command is required. So whenever actually it is generating, the request for the SSH, it will always initiate the request from the loopback rather the physical interface IP.
Okay.
Yep. So champ and okay. It was champ and champ, I believe, right?
Yes.
Username password champ. Connection, so could be
Enable password.
do show run and then line. We'll check it out what is allowed under the transport input all. That should be fine.
Enable password.
Login local. Login local. Enable password, but it is not linked to the that mode itself, right? Yep. Now, though we don't have enable password, we are able to access it. So the reachability wise, we have the reachability over here, and the same SSH -L, and then syschamp 1.1.1.1. Here also we have to configure the same command. But as of now, the telnet and SSH traffic is working fine. This is what our objective.
Okay.
Right? So what we have done in this task is we have configured object group, one for the SSH telnet, the where we have mapped R2s and R4s actually loopback interfaces IP, and another object group I have configured for the services, and where we have mapped the telnet and SSH services, and then eventually this telnet and the object group what we have created is mapped with the access list. Now, if I go to the firewall over here and to say show access list, you will see there are so many access lists configured. Have we configured those access lists? Really?
No.
We haven't configured, right?
Yeah.
But these access lists actually, but we have configured this on the we have configured this in the object group. So it is checking from the object group. Now, in order to achieve the same task, you have to create that many access lists, which means yes, go ahead. Is it clear?
Yes, sir.
Okay, moving to the next task. This task also is all about the object group and the policy map. So it says that you have to configure the object groups 1.1 for this. So you have to create 3 object groups and then map with the access list and all. So we'll share anyways the configuration and everything. It is the same concept that what we have used previously. Nothing much changed. So I'm skipping this task. So this time we must use object groups as per task requirement. However, it must be considered carefully to use a minimum object group as possible. So we are going to this dynamic routing protocols that we have already done it. So we're going to now we in this task we are going to actually see the ASA management, where the task one first is the configure domain name, right, networkerscham.com, and enable adaptive security device manager ASDM access to ASA for the inside network. To accomplish this, put the management location. We have one test. Guys, can you put me on mute?
Sure.
All right. All right, and we have to use also to create username and the password. All right. So let's go to the firewall. All right, now we have show disk. So as of now, we do not have that image, ASDM image. So as I told you, if ASDM image is not here, you won't be able to access this firewall from the ASDM GUI, right? So you have to download ASDM image and then put under this disk 0, and then you have to tell the location also. Is it clear? All right. So in order to perform the activity, we have to configure the domain name in the firewall. So first we'll configure the domain name. Let's say champ.com or networkers champ. networkerscham.com. Domain name. I have to enable HTTP server. HTTP server enable, the part of configuration. If you don't enable HTTP, you won't be able to again access firewall to ASDM. And then you have to allow the IP address or the subnet that you want to allow that PC to access it, right? So let's say there is a PC in particular in the in the direction of in interface. So I'll say HTTP, let's say 10.1.101.253 is the IP address which is there somewhere in the connected to R1, right? And this tells the exactly only 253 can access firewall through the ASDM, and we'll say in means not inbound direction but in interface, means gig 0/1. So as I told you, we should have that under the flash. As of now, we do not have under this flash, right? But we are normally aware of how to, using the TFTP, how to put that image into the flash. Once that file is in the flash, we have to say ASDM image and tell the location. Tell the location that it is there in the flash, and then put the name of the. So let's say ASDM, it is 621.bin. As of now, unable to find flash. This image is not there actually, but that's the command only. And then configure the username, you know, admin, and password Cisco. That's all you have to do. Now you have to go to the test PC, and from test PC you have to, so when you, the IP address of firewall is what? When you browse 10 dot, let's say 1.101.10, which is the IP address of firewall, show interface IP brief. So when you browse this IP 10.1.101.10, right, it'll ask you to whether download the ASDM launcher, or you can download it separately, or you can access it remotely. It depends. So if you have already installed ASDM application in your machine PC, you can use that ASDM and put the username, put the IP address of the ASDM and username and password. It will request for the username and password. Give that, that's all. Is it clear? This we will definitely discuss more. Right, so now in next task, what we're going to learn is how to enable SSH, or could be telnet, in firewall, so that you can SSH firewall. Did you get the requirement? So in the previous task, what we have seen is how to SSH the router. But by default, SSH is disabled in the firewall. You cannot SSH it. The similar way, you have to also enable SSH in the firewall. That's what this task is asking you to do, perform. So it says configure remote management access via SSH version 2 from host IP. Means you should be able to, SSH from IP 1.1.1, which is R1, 1.1.1 to the firewall. Located in the inside network. Make sure user is automatically logged out after 12 minutes. That's something, that you can further fine tune the policies of inactivity. See, if it is inactive, make sure that user is logged out automatically, and use RSA keys of 1024 bits in the length to secure management connections, and password use Cisco, could be anything, Cisco 123 or anything. Is it clear, the requirement? So let's go to the firewall. Right, and configure. So what all command we need? Apart from, do you have to create SSH over here?
Yes.
No, you don't have to create SSH here. Means you have to just enable SSH service. So command is SSH, whom you want to permit that particular IP can SSH this firewall. Let's say 1.1.1.1. So I want to permit 1.1.1.1 to SSH this firewall. Clear?
Okay.
And where is 1.1.1.1?
Router 1 inside.
Inside. So we'll say in. Not in and out, but here in. So means now 1.1 is allowed to SSH. Since we have to also time out automatically for inactivity. So idle time in minutes after which a SSH session will be closed. It is asking for 12. So timeout and SSH version. I'm going to use, and then password.
Right.
Password going to configure Cisco. or 789, anything. All right, and then we have to create this. So crypto key generate RSA module 1024. Yes. Do you really want to replace them? It says some defaults are there. I want to replace, yes. Right? So you can verify here, show SSH. So it will tell you that what all SSH it is. So I see the host allowed to SSH into the system is 1.1.1 in. Clear?
Yes.
I want to, now let's go to the R1. Because I want to perform it from R1. So I will say IP SSH and source interface, take it loopback 0. Isn't it?
Yeah.
And that's all. So let's initiate the SSH. So we'll say SSH -C and then AES 128. So that's there. It is available. Okay. 3DES. We'll use 3DES. And then -L and the name. What was the name that we have configured? Have you configured anything?
No.
Have you configured any username there?
In ASA, right?
Yes, ASA.
No.
We haven't configured, right?
Champ we have configured.
No, that we have configured.
Right.
Okay, let's configure then. So, username champ. And then so we'll say champ and 10.1.101.10. Connection to aborted. Why? Says SSH no match, no matching cipher found, client 3DS, AV server, AES this. So probably I have to also enable these RSAs, which I have already enabled anyways. But in this show run section, what's the error? SSH3 no match, no matching cipher, client 3D ESA CBC server. We'll create once show run section crypto. So where is that crypto key? Okay, so I have to also configure here IP domain name. So networkerschamp.com and crypto key generate RSA module 1024 and IP SSH version 2, and that's all. So connection refused again, champ. Okay, because I have to also mention the loopback, right? So I have to configure. Have I configured source? IP SSH source interface loopback 0. 10.1.101.10. That's fine. That's the IP of, it says SSH no matching cipher found. Show crypto.
So the previous CVC that was something we did not enable such things on basic level.
Show, sorry.
Something the previous that you are matching right here for SSL connection. So we did not do anything with previous on an ASA firewall.
That was the task where we have to perform SSH. The next task is configure banner message so that it will display for successful remote connection via SSH. The banner should include the following message. So let's say welcome to ASA, this fire networkcom.com or only authorized users are allowed to connect. Right, so these are the small, like, you know, the management of the firewall, small configurations of the firewall, but might be very handy, might be very useful while you are managing the firewall actually, isn't it? So let's go to the firewall. And configure this command. So I have to configure the banner and month of the day. MOTG means month of the day, and we'll put the star. So banner and MOTD, let's say welcome to networkers, you know, champ. Clear? So networkerschamp.com, and the next is we have to configure the banner month of the day, and that is for the authorized users. So MOTD, and we'll say only MOTD only authorized users. Let's say authorized users. And end of the, so that was this banner MOTD star, that was actually the initial as in that was the beginning of the message where this MOTD welcome to networkerschamp.com, and then this you know, only, this is for only authorized users, and then we have to end this with the same command MOTD and star, what we have started before. So verification, show run, and then banner. So this is the banner we have configured. Right? Or if you say show banner, it'll tell you what all. So welcome to networkerschamp, only authorized users. So this is the banner, what you have configured. So once we have initiated the SSH and it is successful, which is in this case it is not. I have to check why it is not. Or let me check this -C. So -C and then 3DS. This itself with the connection, it says the no, it's not. But yes, once this is working, I mean, there is definitely some issue with the firewall, which it is not accepting. Next task is configure ASA as NTP client, right? And configure R1 in this case as in the NTP server. Means firewall should synchronize the time from NTP server. So as you see this diagram, this is going to be your NTP server R1, and firewall is going to be NTP client. So
Can you
it,
share the task screen?
yes, we'll do that, right? And then it will all right. So this task I was talking about. So we're going to configure now the ASA NTP client in the firewall and then the NTP server as in the router one with this IP address. We have to also make sure that they are using authentication between them. So we are having idea about the NTP. What is NTP? NTP is basically a network time protocol, all right? And the idea is that in your industry, in your company, all the devices should get synchronized or should have the same, accurate time. It will really help you to troubleshoot. It will really help you to audit, the logs which you are collecting maybe in syslog server or, the other maybe method could be SNMP or something, but it will really help you to troubleshoot and audit in case if you want to audit the logs, because all the devices will have the same time, and that is the idea of, and that is why we have NTP. So we are going to configure one device as an NTP server, and maybe the rest of the devices will be NTP client. So all NTP clients will get synchronized with the NTP server and synchronize the time also. So in this case, one is going to be NTP server and firewall is going to be NTP client. Is that clear? So let's go with the configuration. Initially with the firewall. So to configure, one moment. Let's start with the R1 first. So we'll configure NTP authentication over here, NTP authentication or authentication key. We'll configure authentication key 1 and MD5, now Cisco Ntp. That's the key, right? Ntp authenticate. So whenever it is someone is coming for the NTP synchronization, it should be always authenticated. Trusted key 1. I'm going to give NTP master. So this command tells you that tells that R1 is the master or the server for this Totem level 4. And NTP source loopback 0. Loopback 0 means all the rest of the devices will consider 1.1.1 as in the server. I don't want to make it in the physical interface IP as in the server. So I'm going to configure loopback as in the source.
What is this master for?
Master 4 is this Totem level. So NTP master is the command to configure that the R1 is a server.
Okay.
And 4 is this Totem level. So which is there between 1 to 15. The lowest Totem is the highest accurate.
Okay.
So here we are going to configuring 4. Clear? Coming to the firewall, same NTP authentication. It's NTP authentication key 1 MD5 Cisco Ntp. This is what we have configured there. Ntp Authenticate and Ntp Trusted Key 1. And who is your Ntp server? So this command will tell that 1.1.1 is the Ntp server where I have to use key 1, and the source is, where is it? In out or DMZ? It is in the in. Is it clear, this commands? Right? So verification, I can check over here, show Ntp and association details. So you see here 1.1 configured, authenticated also, and these are the the packets being actually accepted. As of now it is saying invalid and insane. It should be actually sane and then the valid. As of now it is saying unsynced and start on 16, so might be it is little early. So show Ntp association. All right, I see that synced master 1.1049 port, so that's fine. It should be actually, I see this synced, but here association details. Show Ntp status. Also, we can check this. As of now, clock is unsynchronized.
And it was just showing, I think, configured, not become as a master.
Sorry?
The Ntp associations.
Okay.
It was just showing as it was configured, just like static.
Yeah, that's what I'm saying. It is not synchronized.
Okay.
It might take some time also.
Yeah.
MD5, that's the key. Authenticate, trusted key 1. Ntp server 1.1.1 find source in. The configuration is fine. Authenticate, trusted key, source look back. So normally in the routers, actually, it does take some time. Clock is unsynchronized, nominal frequency. If I check the association, it just configured 1.1.1, 0 or reference. Reach 0. It says that the pole band 47, but start time, but reach is 0. So if I save the configuration, sometimes we have to also reload the device. But that's only sometimes, not every time. Ntp clock or update calendar.